नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर IIT JEE and NEET. This video is regarding Bronsted-Lowry acid-base concept. Today we are going to learn about the first thing is strong acid and strong base in aqueous medium, and the second point is how to calculate pKa of water and pKb of OH minus ion, pKa of H3O plus ion and pKb of water. So this table is taken from Solomon, and where in this table they are mentioning relative strength of selected acids and their conjugate bases. So like for all strong acid they have given pKa value which is negative. We are interested here about H3O plus ion. They have given that for H3O plus ion the pKa value is minus 1.74. If H3O plus ion is an acid, its conjugate base will be water. So we are going to find out what is pKb of H2O. Same way they have mentioned pKa of water which is 15.7. If I write up to 2 decimal place, it should be 15.74. So if water is acid, its conjugate base is OH minus, so we have to find out what is pKb of OH minus ion. So from the table we are going to learn that how to calculate pKa of H3O plus ion, pKa of water and pKb of water, pKb of OH minus ion. So we have to prove these things. We are starting from water. Like if an acid like acetic acid, when added to water, it will dissociate to form H3O plus ion and acetate ion. Similarly here we are considering water as an acid. So when this water molecule will dissociate, it will form H3O plus ion and itself converted into OH minus ion. So if I want to write that what is the dissociation constant Ka of this water, it should be the concentration of H3O plus ion into concentration of OH minus ion upon concentration of water. So we know that the numerator is ionic product of water. If nothing is mentioned at room temperature, we consider room temperature. At room temperature, ionic product of water is 10 to the power minus 14 divided by molarity of water. If density of water at room temperature is considered to be 1 gram per ml, then we can write that molarity of water is equal to 1000 divided by 18, and if we simplify this, we can write that this value is equal to 1.8 into 10 to the power minus 16. So if I want to write what is minus log Ka will be pKa of water. On the right hand side, this value will be minus log of 1.8 into 10 to the power minus 16, which can be written as 16 minus log 1.8. The value of log 2 we know 0.3010. Definitely the value of log 1.8 is less than 0.3010. So if we write this value, we can write that log 1.8 is 0.26. So on simplification, we can write that this value is equal to 15.74. So from here we can say that pKa of water is 15.74. Similarly, if water is acid, its conjugate base is OH minus. Like when ammonia is added to water and ammonia is acting like a Bronsted base, it will accept H plus from water to form ammonium ion and OH minus ion. Similarly, this OH minus ion is a Bronsted base, so it will accept H plus from water to convert into water and OH minus ion. So same way, if I write that what is Kb for OH minus ion, it should be the concentration of water molecule into concentration of OH minus upon concentration of OH minus. OH minus in numerator and denominator will cancel out, so we can write that Kb of OH minus is concentration of water. And at room temperature, if density of water is considered to be 1 gram per ml, we can write that this value is equal to 1000 by 18. So if we simplify, if we take minus log on both sides, we can write that minus log Kb is pKb, which is equal to 3 minus log 18. On further simplification, I can write that this value is equal to, this is minus 3 plus log 18. So on further simplification, I can write that this value is equal to minus 2 plus log 1.8, or if we further simplify, we can write that this value is equal to minus 1.74. So we can say pKb of OH minus is minus 1.74. Same way we are saying that H3O plus is acting like an acid. Like if acetic acid is added to water, it will form acetate ion and H3O plus ion. Similarly, when H3O plus is present in water, it will give H plus to water and it will convert into water and H3O plus ion. So the dissociation constant of H3O plus can be written as concentration of water molecule, concentration of H3O plus ion divided by concentration of H3O plus ion. So in numerator and denominator H3O plus ion will cancel out. So we can write that 1000 by 18, and if we take minus log on both sides, on simplification we can write that this value is equal to minus 1.74. So from here we are getting that pKa for H3O plus ion is equal to minus 1.74. Same way, if H3O plus is acid, its conjugate base is water. So when water is behaving like base, means it will accept H plus from other water molecule to form H3O plus ion and OH minus ion. So Kb for water, here we can write that it is equal to concentration of H3O plus ion, concentration of OH minus ion upon concentration of Kb of water is equal to concentration of H3O plus ion, concentration of OH minus ion upon concentration of water. Ionic product of water at room temperature is 10 to the power minus 14, and density of water is 1 gram per ml. Then molarity of water is 1000 divided by 18. If we further simplify, this value is equal to 1.8 into 10 to the power minus 16. If we take minus log on both sides, from there we can write that this value is equal to 16 minus log 1.8, which on simplification will give 15.74. So pKa and pKb of water is same, and that is equal to 15.74, and we know that water is amphoteric in nature, so it can act as acid as well as base. So this is our first part. Let us try to understand that what is the meaning of strong acid and strong base in aqueous medium. We know that NaOH is a strong base, but NaOH is not Bronsted base, it is an Arrhenius base. So we are not going to discuss here NaOH because we are discussing Bronsted. So H minus is Bronsted base because it can accept H plus from water and it will form hydrogen gas. So H minus is a base. Now we have to see that why H minus is a strong base. So when H minus is added to water, it will take H plus from water and convert it into hydrogen gas, and hydrogen gas will liberate out. Since the product is moving out of the system, this reaction will move more in forward direction. That's why H minus is a strong base here. So we are comparing, there are two bases in this system, H minus and OH minus. Since the reaction is moving more in forward direction, we can say that H minus is a stronger base. H minus is a stronger base. So in aqueous medium, if some base has dissociation constant greater than that of OH minus, then we'll say that that base is a stronger base, because we have calculated the pKb of OH minus, which is minus 1.74, and it means that Kb of OH minus is 1000 divided by 18. So if there is a base whose dissociation constant is greater than 1000 divided by 18, then we can say that in aqueous medium it is a stronger base than OH minus. Same way, for hydrogen chloride is a strong acid. When it is added to water, it will form H3O plus ion and Cl minus ion, and we have discussed that there are two acids here, and the pKa of H3O plus, we have already proved that this is minus 1.74, means Ka of H3O plus is 1000 by 18. So HCl here, because it is a stronger acid, it will move more in forward direction. We can say that this is a reversible reaction, almost irreversible reaction, because it is moving more in forward than backward. So we can say that HCl is a stronger acid than H3O plus ion. So something in water, like here I can say that Ka of H3O plus ion is 1000 by 18, and the HCl Ka value is greater than 1000 by 18. That's why we can say that HCl is a stronger acid than water. So in aqueous medium, when we are saying a strong acid, basically we are saying the acid whose dissociation constant is greater than that of H3O plus ion. And in aqueous medium, when we are saying a strong base, we are saying a strong base because the Kb of that base is greater than Kb of OH minus, and Kb of OH minus is 1000 by 18. So I hope that this video is useful to you. If it is correct, please don't forget to like and subscribe our channel. Thank you.